Hi everyone, welcome to Vertical Coding. In today's video, we are going to look at Earth geometry. Now, in particular, we are going to focus on what is called the radius of a latitude. So we have to differentiate. There is what we call a radius that is coming from the center of the circle, as well as the radius that is not coming from the center of the circle. Now, in this video, I want to make you understand what is the difference between a latitude as well as a longitude, but much more to understand where does the formula for finding the radius of a latitude come from. So if you really understand what is, in terms of trigonometry, this is going to be so straightforward and easy for you to just understand that, so that even the formula can be fundamentally understood. So if you're new for if you're watching for the first time and you're new to my channel, Facebook, as well as TikTok or rather YouTube, remember to subscribe, like, and share this video. So without much further ado, let's dive into this question, or rather this understanding. So now, in principle, what we have is we are looking at the structure of the Earth. So we have, this is a south and north. So we have north and south, okay? And then we have these lines. So we have lines north and south, okay? So what you need to understand is that first of all, we have to know this. Now, it's very actually much important for us to understand this compass. So this part is the western, this part is the eastern, okay? Now, once you do that, we can now know that this is east and this is west. This is west and this is east. So from there, okay, so we have that compass. And then the other thing that we're supposed to understand now is that the lines that comes or that runs from east to west. So this is a latitude, okay, and this is a longitude. Okay. So now, what is very much important in Earth geometry is to really understand what is a longitude and what is a latitude. And you have to be able to extract the points, okay, that is given on this imaginary Earth surface or structure, okay. So once I'm able to differentiate and be able to understand how to collect the points, how to collect the point, then that becomes very easy and straightforward. Now, moving on. So now, the point is this. When you have this Earth structure, we have this point, okay? Now, this point actually could be the center of the Earth. That is the most important thing that we have to understand. We have to look at what could be possibly the center of the Earth. Now, some people would also actually don't give out an actual answer, or just to understand what is the exact position of that center of the Earth that we are talking about. So, but of course, you can look at this shape and be able to just guess around that region. We can actually pick that. So this appears to be the center. Okay. Now, what I want you to understand is that when you're looking at the Earth, okay, you're just simply trying to look at the grids of lines that are running horizontally as well as vertical. So what you're looking at, so basically you're just looking at something like this, okay? And because there is a conception that the earth is actually spherical or sort of like circular in nature, and this is the reason why we're actually drawing something like that, okay? Now, when you look at this point, okay, then what I can do is I can extend this line, for example, from this point, okay? So from this point, okay, to this point, somewhere there, and this point to that, and then bring it back like that. Now, when you have something like that, then now we can actually borrow something from trigonometry, because we know that there's something that we want to understand. We are talking about the latitude, okay? So this 30 there. So from there, I can now extract the point, which is this now, what you need to understand that from this point, okay, this angle, okay, this angle there, this angle, we can actually call it actually theta, okay? And also, because this is a z, okay, this is also theta, okay? So we have some simple angles that we're trying to come up with, okay? So then we can see that this part can be simplified by looking at this point. So what you're saying now is, remember that there is 30 there. So this 30 is simply, the 30 is there. And because this is z, this is something that we have as well. Okay. Now, you have to understand one key concept, okay? There are two kinds of radius, okay, or two kinds of radii, okay. This means that we have the capital R, or the radius that is represented by capital R, and then we also have the radius with the small r, okay. And then from there, this capital radius, okay, is known to have this number, okay. It is known to have that number, and this one we don't know. And that is basically what we are trying to come up with, or rather find the radius of the small circle, or rather the radius of a latitude, which is this latitude 30. Okay. Now, so this point is small r, okay, and then this one there is capital R. Okay. Now, from the concept of trigonometry, then we understand that this is a 90-degree, okay? And then we can now invoke something that we already know. We know when it comes to trigonometry that we can use the cosine, okay? The cosine function to find the side representing the small radius with a small letter r, okay? And what kind of, how is that going to be? Okay, so now let's see. So what this is going to be is, we know that this capital R is the radius that has been estimated, or rather approximated, by mathematicians, geographers, astronomers, or even other experts, okay? And that number with representing the small, capital R is just 63.70, or rather in nautical miles is 34.37. Okay. Now, when you look at this small arrow, it is actually not coming from the center of the Earth. Now, from the center of the Earth, it has this point, okay? Right at this point, that's where the center of the Earth is. So this implies that from the center to any point on the circumference, okay? From the center, okay, to any point on the circumference, that is the radius of the circle from the center. But what we're looking at is the radius of the circle, of the small circle, which is the latitude, and that is this, the 30 degrees there. Okay, this one there. So then, from this concept, then we can actually use trigonometry to understand what that is like. And now let's do that. So from there, now we know that we have this, and this is the hypotenuse, okay, and this is the adjacent. So from this one, then we can say SOHCAHTOA, okay, and then I can use this ratio, okay, meaning it cos adjacent hypotenuse. And this is what I have. So I'm looking for the adjacent. I have this angle, and then I have the hypotenuse. So therefore, it's going to be cos theta equals to a small r over capital R. Now, because I'm looking for the radius, okay, for the radius of the small circle, which is this a latitude, and this one is 30 degrees, okay. So what is going to happen now is that I can make now the small r the subjective formula, okay, and this, we can do this, okay, and this is going to be, okay. And now this is where now the formula comes from. Many people would just actually give you that this is the formula that you must be able to use. And now in this video, I'm trying to make you understand where the formula comes from, okay? Because understanding the concept that I've explained here, they are very actually, useful and very cardinal to help us understand how this formula works out, okay? So thank you so much for watching, and we'll continue in the next video under this part, which is just looking at the radius of a small circle. Now remember, when I say small circle, I'm referring to the latitude. When I say great circle, I'm referring to the longitude, which are these lines, vertical lines, and the latitude are these just horizontal lines. So thank you so much for watching. Remember to support me. Subscribe wherever you're watching from, YouTube, Facebook, TikTok. Okay, you can just find me there by just typing Radical Coding. So it's bye bye. Thank you so much for watching, and I'll see you in the next video.